going to learn about this rule called CP/CTC, and what it allows us to do. Helps us to prove parts of two congruent triangles are congruent. Okay? CP/CTC stands for corresponding parts of congruent triangles are congruent. It's just a statement. It's not a theorem, not a postulate, nothing special about it. It's just a statement that has to be true. Corresponding parts of congruent triangles are congruent. It says that if two triangles are congruent, then all their corresponding parts are congruent. That's what the statement says. Okay? I'll pause while you get caught up. It's really important that you understand that you must first know the triangles are congruent before you can apply this rule. Okay? You must first know the triangles are congruent before we can apply this rule. If you pull out your page that has the triangle congruent statements on it, underneath all the 5 triangle congruent statements, there's CP/CTC. Stands for corresponding parts of congruent triangles are congruent. And here's a little hint right here that we need to remember. The CP/CTC can only be used in a proof after one of these statements. After one of these over here. Okay? It can only be used after one of the triangle congruent statements. So once you've proven the triangles are congruent, which is what we spent the last 3 days doing, right? Writing proofs to show two triangles are congruent. Once we've proven the triangles are congruent, then we can make a statement about corresponding parts. And that's when we would throw this in. So on our proof today, we're going to prove triangles are congruent, and then after we've done that, we'll use this rule to make statements about other parts of the triangle. Okay? Let me raise this up a little bit for you guys, in the middle and the back. Okay, this is the only thing new today. Everything else we've done, I should say everything else we're doing today we've done in the past. And so here's an example of a question on the test. I'll pause so you can copy this down, and then we'll talk about how to answer it properly. All right, on this question, there's really 3 questions here. It says to state why the triangles are congruent. That's the first question. Give the congruent statement. That's the second question. And then tell what other parts are congruent. It's the third question. So there's 3 things we have to answer here. To begin with, it says state why the two triangles are congruent. Now, it's not saying to write the whole proof. It's just saying the punchline of the proof would say triangle what congruent to triangle what because of why. So when you look at this picture, how do I know that these two triangles are congruent? And so again, we're looking at one of these. These are the Y. We haven't done HL yet. So we're really looking at these first 4. So if we go back, yeah.
Side angle, side.
Side angle, side, okay? You're probably saying they both share this side, right? So that would be, if we wrote the whole proof, why would I know that's equal to itself? Reflexive. These are perpendicular, which means they're right angles, which means right angles are congruent, right? So there'd be 2 steps to get to that, but we would say those are congruent. And then it was given to me that these were congruent, right? So we have side angle, side. So the Y is by side angle, side. That's why they're congruent. Okay? The congruent statement means on the statement side of that punch line of the proof, where we said triangle congruent to triangle, what would we write here? triangle ABD That's correct. That's not the only way you could write it, but that's one correct way. She named the first triangle ABD, and then she matched this one up in the same corresponding order. Okay? So we would say that this statement is true by this reason. And now that I know that's true, we're going to apply CP-CTC, which means once the triangles are proven to be congruent, then all corresponding parts are congruent. So at this point, they want us to tell what all other corresponding parts are congruent. So we'll come over here and we'll say by CP-CTC, there's three other facts that we can write. And the reason there's three others is because we've already used three of them to say the triangles are congruent. We used BD and BD. We used angle ABC and angle, I'm sorry, I said it wrong. Angle BDC and angle BDA, these two angles. And we used these two sides. So there's three other facts. Jackson, can you name one of them?
Segment AB is congruent to segment CB.
That's correct. Segment AB is congruent to segment CB. Okay? Good. How many sides have we used now in our pictures? Three. So what's left? Only angles. Right? We've got this side, this was given to us, and this we said by reflexive, and then we just made this statement. So we've used all three sides, and we've used these two angles. So the only thing left are angles. Brooke, can you name a pair of angles? Good. Angle BAD, angle bad, congruent to angle BCD. Now, did she have to use three letters there? No. Because at A and at C there's only one angle, she could have just said angle A is congruent to angle C. Okay? And there's one last one. Amber? Angle ABD is congruent to angle CBD. So in other words, this angle is congruent to this angle. I forgot to mark this one. Okay? So we have three more statements. Now when you're writing a proof, they're not going to usually ask you to identify all three of them. They're just going to be looking for one of those three. Okay? But this is how we would do this. So on this question, when they say, why is it congruent, write a congruent statement and tell what other parts are congruent. This is what they're looking for. This is the why. This is the congruent statement. And these are the other parts. Okay? So on those types of questions, they're not asking you to write the proof, just identify this information. All right? Any questions on this? Anybody not done with it yet? Okay. Moving on then, let's write one proof. You see here, they're not asking us to prove triangles congruent, they're asking us to prove that segment AD is congruent to segment CB. I have to go back and put those on. Oops, let me pause that while you copy it down. I'm gonna write this proof, could you tell me what I probably write the first step? The given. And so I would say segment AB congruent to segment CD, and segment AB parallel to segment CD. And the reason for that was given. Okay? Silas, is this fact direct information or indirect information? Okay? Because it directly tells us one of those three things we want to know, right? It's saying side congruent to side, right? Segment congruent to segment. How about this one, Silas?
Indirect.
That's indirect, because it's not saying things are congruent, it's saying they're parallel. Which is important because I'm going to use that to figure out what to write here. I'm going to use the fact about those parallel lines to say something's got to be special about parallel lines. Okay, Allison, do you remember the three things I said always consider when you're given parallel lines? So can someone help her with one of them? I think she'll probably get the other two then. Go ahead, Brandon. Corresponding angles. There's one. What's the second one? Alternate interior angles. And the third one? Same side interior. Okay, so if we look up here, and if I highlight my parallel lines in my transversal, okay, corresponding angles would be like this angle and this angle, right? Now let's go to Rebecca DeBrill now. Do you agree that those would be corresponding angles? See how they're in the same position, top left, between my parallel lines, my green lines, and my red line, my transversal? Okay. Are those helpful in this picture? No, because this one up here is not even part of the picture, is it? And this one here is only partly part of the picture, this part right here. The rest of that's not part of the picture, so that's not helpful. And if I look at this one, I come up here, again, it's not even in the picture, it's off to the side of my screen so far. Okay? So it's not in the picture. So corresponding angles are not going to be helpful here. All right. So let me undo some of that mess I just cluttered up there. And now let's look at same side interior. Like this one and this one. Those are same side interior. Are those helpful? No. Or if I go the other two same side interior, here and here, are those helpful? No. Usually same side interior is not going to be helpful. Does anybody know why? It's not what I just said. It's not because they're not always inside. Jackson?
Because they won't be congruent, but
Right. They don't tell me things are congruent. They tell me things are supplementary. They tell me they add up, right? Because the lines are parallel, they add up to 180. And so that's not helpful either. And so the only thing left is what? Alternate interior. And again, it has to be between the green line and the red line. So it would be this one and this one. Those are my alternate interior angles. Are they part of my picture? Yeah. And are they congruent? Yeah. Why are they congruent? What am I going to write here? Why are they congruent? AIA, alternate interior angles. It's actually a theorem, alternate interior angles theorem, which says if the lines are parallel, then alternate interior angles are congruent. So if you just write AIA, we're good. All right, so what's someone that hasn't answered a question for me yet today? Yeah, Katie?
So angle ABD is congruent to angle CDB.
CDB, good. Very good. Angle ABD, that's this angle, Now, could she just call it angle B and angle D?
No,
No, why not?
because there's two angles adding up to make one.
Yeah, there's too many angles going on at that intersection, isn't there? There's at least two, okay? And if you ignore the red transversal, there's three, right? So there's three angles there, and we wouldn't know which one you're talking about if you just said angle B. All right, so I have those two angles. Let's see if I can pause it. All right, we cleaned our picture back up, and we have how many facts? How many facts are in this bottom triangle here? Three. Are you counting the parallel lines? Is that one that says something congruent to something, though? So the ones that matter to us, there's how many? Two. Yep, good. There's this angle and this side, congruent to this angle and this side, right? And we need how many facts? Three. And so there's got to be one more there. And I've used, this was direct, this is indirect, but I used that to get this direct statement. So I have two, but I need a third one. Someone that hasn't helped me yet, can you help me? Brianna, you haven't helped yet.
Segment BD is congruent to segment DB.
Segment DB is congruent to segment BD. Nice. This is the same segment in both triangles, isn't it? And it's equal to itself. And she switched them around. You notice that? She switched around. Here's a good tip as to why. See the BD in this angle is angle ABD, and over here it's angle CDB. They used the same points, but they had to switch the order around. Okay? So that's correct. Now again, I wouldn't hammer you if you said DB congruent to DB, but it's better if you can recognize when they're switched around and when they're not. Okay? Now I have three facts. Right? Jared, you've been pretty quiet this morning. What would my next statement be then? Oh, I'm sorry. What's the reason? Reflexive. Good. And it's reflexive property if you want to write property. What's the fourth step going to be, Jared?
Prove that segment AD is congruent to segment C.
So you think we're ready to write that? Let's talk about that for a minute. If I was ready to write that, what would my reason be?
The only way we could do it before we got the statement of congruence would be if we did it during the, like all the different steps.
Okay? So we'd have to have some information that would lead me to know that, though, right? And we haven't. So what he's saying is we must first prove that triangles are congruent. That's what he meant by before we write the statement of congruence. He meant the triangles are congruent. So we must first say the triangles are congruent. So my next step is, do I have enough information to know these two triangles are congruent?
Yes.
Yeah. Brooke is saying yeah. I would agree with her. So I'm going to say triangle ABD is congruent to triangle CDB. I'll slide this up a little bit. For what reason? Side angle side. I have two sides and the angle between them of the top triangle congruent to two sides and the angle between them of the bottom triangle, so that's side angle side. Okay? Now once I've proven the triangles are congruent, now I'm ready for this last step. Segment AD is congruent to segment CB. You know the reason? I know. I know what you're doing. I was just asking if you know the reason. After we use one of these, we can use this. right? Which stands for corresponding parts of congruent triangles, which means once I've proven the triangles are congruent, I can state all the corresponding parts are congruent. And so my reason for knowing this is true is because of CPCTC. Once I've proven these triangles are congruent, after you make this statement here, then you can use CPCTC to say anything you want about all the other corresponding parts. I shouldn't say anything you want, but you can make the statements that they're all congruent. Okay? This is how you're going to add. So the only new step today is this one right here. And you notice it follows this statement. It always comes after this statement. Okay? Always. All right. Now, I know there's some questions on there, but that some of you would say, well, I still don't get it. And that's okay. I'm not saying it's okay you don't get it. I'm saying it's okay you don't get it yet. Still lots of time. Okay, we have another at least 3 weeks before well, this week and 2 more weeks before we're going to be testing on this. Okay? But we will be, this is going to be combined with Chapter 5, this unit test. And so we'll be learning some new things. We'll take a break from this. But those of you who still don't get it can keep asking questions. You can keep practicing. I can keep working with you. Okay? So don't panic if you don't get it yet. There's still lots of time. So the question is, do you have any questions that you want to ask now on this proof? You can ask. It's okay.
Well, I don't know, you know how you get the side angle side, is it possible?
You don't know how we got side angle side?
I just get confused by that sometimes.
Okay, let me do this. Let me draw this top triangle, just freehand up here. Looks like this, and it's DAB. And the bottom triangle looks like this. It's a little bigger, sorry. And it was DCB. And through all of our statements we gave over here, AB was congruent to DC, right? And angle ABD, so that was this one, was congruent to angle CDB. So those are congruent. And then we said that DB was the same side in both, so those were congruent. Okay? So when I separate that from the clutter of all the other stuff, you see that in this triangle I'm given 2 sides that are marked, and this is the angle that's between those two. Do you agree? And then over here I have 2 sides, and then this is the angle between them. And so when I go back to this, and I'm looking at what information do I have, well, I didn't have 3 sides, did I? And I had 2 sides, and I had the angle that was sandwiched in between those 2 sides. And so the reason I knew they had to be congruent was because of this theorem, which says, this postulate says, if you know 2 sides of one triangle, and the included angle, meaning the angle between them, is congruent to 2 sides of another triangle and the angle between them, then those 2 triangles have to be congruent. It's like minimum criteria. Okay, it's like to pass this class, your minimum criteria would be a 58.5%, right? To get an A, your minimum criteria would be a 92.5%. All right? Depending on what you want. Well, if we want to prove triangles are congruent, then our minimum criteria would be we'd have to know one of these 5 things is true. Okay? And so in this one, we discovered that it was side angle side because of the place, the location of the 2 sides and the angles. Okay? Now, what if instead of that side I was given this angle. Angle,
Angle side.
yeah, because the side is between the angles, right? Okay? And if I, instead of that angle, if I was given this angle,
Angle side.
angle, side, because now my side's not between my angle, is it? It would go this way, go angle, side. Angle, side. Okay? So that's how we determine which one we use. We just look at, after we write all our statements of fact, we look at the order in which the information is in my pictures, and then I choose, it's either side, angle, side, angle, side, or in a couple days we'll learn about HL. Okay? All right. Good question. Any other questions on this proof? Okay. Today we're just doing the odds and number 18 up to 17. And that proof took 19 minutes where I thought it would take 10. So we're down to 25 minutes. But you still have a good start here.